Okay. When we're talking about area with shapes, particularly quadrilaterals, you all have learned length times width. That was the terminology you more often than not were taught. And with rectangles or squares, that would work. Let's just say this is 2 and this is 3. You would say this is 6 units squared. And if both of these are 2, you would say that's 4 units squared, because length times width is area, right? And back in the day, length and width, you would think of length as being the longer side and width being the other side. Well, to take it up a notch, we're going to learn about a slightly different way of thinking of it, but it's still the same thing. From here on out, you're going to want to think base times height is area. The reason for that is they're trying to move away from you automatically thinking longer side is one thing, shorter side is something else. So to sketch it, I'm going to draw this. And by the way, this is for a parallelogram. Okay? And parallelograms include parallelograms, squares, rectangles, and rhombuses. I'm not sure how to parallel that or plural that. Okay? Base times height. So in something like that drawing there, that little sideways diamond looking thing, the base is defined as this in this drawing, and the height is defined as the top to the bottom. That's the height. Not this, okay? That's the height. And actually, if I took this piece, picked it up, and placed it over here, it would become, like that picture, a rectangle-looking thing. In which case, base and height would be pretty clear. Okay, so I'm going to pick that up for just a second and place it over here, so you could kind of get an idea of what I'm talking about. Okay, so if I move this piece over to here, the base is still the same, but the height is a little clearer. Okay, that's what they've got drawn there. You guys okay so far with this? Mm-hmm. You okay back there? Awesome. All right, so in this guy here, the base is, let's just say 8 units, and the height from here to here, I'm going to say, is 4 units. So this guy would be 32 units squared, right? Mm-hmm. And we have the same area here and here. It would be 32 units squared. Just picked up and moved over. Not that I'm very good at drawing these. Example 1. The base of a parallelogram is 5 inches. The height is twice the base. So it doesn't matter if I draw it like this or like this, as long as I indicate that my height from top to bottom is twice whatever the base was. Twice whatever the base was. Okay? Same exact idea. In any case, what would it be? 10?
Yes. 50 inches.
10 is the height, which doesn't look like it is in my drawing, but so the area is 50 inches squared. 50 inches squared. Let's go to the next page. Let's look at checkpoint 1 on the bottom of 522. It's just a slight mean. And And the base, this is checkpoint 1. What is the base?
6
It is 6.
feet,
And the height,
5 feet,
so if I asked you for the area, you would tell me 30 feet squared. Good. A trapezoid is slightly different, and that is at the top of 522. Let's do trapezoid. So a trapezoid, again, is that goofy looking thing. So in this case, this side is parallel to this side here. These two guys are not. They're not parallel to one another. Trapezoid. The area of a trapezoid, and this is going to seem a little strange, the best thing I can tell you is to memorize it. The area is 1/2 of the sum of the two bases. Well, what do you mean by the two bases? I'll show you here in a minute. Multiplied by the height. That being said, the two bases are the parallel sides. Okay? Those are the two bases. And if it was drawn this way, it would be the two parallel sides. Okay? I know that seems weird, but that's just how you got to think of it. The height would be the other measurement then. Okay? The two bases are the two parallel sides multiplied by the height, which is the other measurement. So in the case of this one that I've sketched, let's just say we'll make this 3, we'll make this 5. So it would be 1/2 of the sum of 3 and 5 multiplied by the height, which I'm going to call 4. So 1/2 of 8, which is 4, multiplied by 4. 1/2 of 8, which is 4, times 4. So the above one would be 16 units squared based on that data. Okay? Again, that formula is going to be your best friend. This one over here, let's make this one 2, and this one 4, and this one 3. So, area is equal to 1/2 the sum of the bases. What are the bases?
2 and 4,
2 plus 4. Multiplied by the height. What is the height, which is the other measurement? 1/2 of 6
3,
times 3. So the area would be 9 units squared. So there's yet another example for you. This formula is going to be critical. When you come to me later and say, I don't know how to find the area of a trapezoid, I'm going to say, look in the book, because it's right there for you. And their example there uses a trapezoid with bases of 5 and 7 and a height of 4. Find the area of a trapezoid in example 2. Interestingly enough, that quilt that you see there is all a bunch of trapezoids smashed together to kind of form that shape. The diagram at the right shows one of the trapezoids. I'll draw it. Trying to draw it the same way they did. Find the area. What's the formula for the area of a trapezoid? Area is equal to
1/2 the base
1/2 the sum of the bases
times the height,
multiplied by the height, right? What are the bases?
4 and 9,
4 and 9. And what's the height? 2.5. 1/2 of 13, 2.5. 1/2 of 13,
6.5,
6.5, multiplied by 2.5, Okay, 1/2 of 13 is 6.5. So what does area become as a result? Looks like 16.25 centimeters. Somebody who designs things or sews at all would care about this, because when they go to the fabric store and they say to the fabric lady, I am making 400 of these, and she sketches this out, I'm making 400 of these little panels. How much do I need? Well, the fabric lady, if she doesn't know this, is going to say, I don't know. Sorry. Can't help you. Excuse me. So this is extremely useful. When you are building things, oftentimes you have to calculate this. Okay, so we've done parallelograms, which is simple base and height, and trapezoids. Let's do checkpoint 2. So if I sketch it like this, one half the sum of the bases multiplied by the height. Solve it. Solve it. Yes, ma'am. Don't do it out loud. Everybody's working it. Solve it, folks. 1/2 the sum of the bases. What's up, Amy?
I got the answer.
Okay. Thank you. 1/2 the sum of the bases multiplied by the height. Really, what'd you get? She's right. 3 plus 9. Forgot to label the height, but you guys could see it. 1/2 of 12 times 8.5. And you should have come up with 51 meters squared. Did anybody not come up with 51, and do you need me to show it? Please, speak now. Okay. Example 4. Let's just say, again, I am creating something, but I'm not completely sure of all the information. I was given part of the information. Take example 3. And I keep sketching the same type of trapezoid, so if it doesn't fit with the data, I'm sorry. I'm just using it to help me figure stuff out. The height of the trapezoid is 6. Looks good so far. One of the bases is 8. The area is 54 square meters. Find the other base. Okay? Area is equivalent to 1/2 the sum of the bases multiplied by the height, right? Do I know the area?
Yes.
What is it?
54.
1/2 the sum of the bases. One base plus the other one. Do I know the height?
6.
Okay. So far I've got everything plugged in. 1/2 the sum of the bases times 6. I don't know if you guys remember this, but when you're multiplying, the order that you multiply doesn't matter. So this is literally saying that multiplied by that, multiplied by that, right? But how do I multiply b plus 8? I don't know what half of b plus 8 is, but can I figure out what half of 6 is? Half of 6 is what?
3.
3. So that has just solved that. 3 times b plus 8 now is 54. So I made a decision that I cannot really figure out what half of this sum is because I don't have all the information, but I certainly can figure out what half of 6 is. Do you guys remember when you have to multiply the outside thing over the pieces within the parentheses, that you have to multiply that number over both pieces? Anybody know what 3 times b is?
No.
3 3 times b, very good. Anybody know what 3 times 8 is? Good. If I were you, I would solve by, of course, subtracting. So b is what? 10. 30 divided by 3. And if you wanted to test yourself, you could. You would say 1/2 of the sum of the bases multiplied by the height. 1/2 of 18, which is 9. Is 9 times 6 54?
Yeah.
Then you know that 10 is correct. Okay. This is no joke. Example 4, actually, in my basement office, I have a setup similar to this. And it did take a little bit of manipulation trying to figure out what would fit where. And it's a corner-shaped desk. So I'm going to do this one with you. Example 4, you're building an L-shaped desk. So boom, boom. This is my version. And it's not pretty. That'll work, right? The dimensions of the desktop are shown. Okay, so we're looking down on it, people. From here to here, I know it's 3. From here to here, it's 5. From here to here, it's 8. This is still 3. I've got a 4 and a 9. All of this is feet. Let's solve this trapezoid right here. Hope you can see that it's a trapezoid. 2 sides are parallel. These are not. So this is a trapezoid. This trapezoid here, the area is equivalent to 1/2 the sum of the bases. What are the bases? I know it's sideways. We can do this. Multiplied by the height. What's the height? 3. What's 8 plus 5? Sorry. 8 plus 5 is 13?
Yes.
Timber. What's 1/2 of 13?
6.5.
What's 6.5 times 3? 19.5? Am I done?
No.
Okay, let's do this one. Okay, area is equivalent to 1/2 the sum of the bases. What are the bases?
4 and 9.
4 and 9. Multiplied by the height. What's the height? Seriously? Are you kidding me right now? 1/2 of
13. Isn't it the same?
looks that way. 6.5 times 3, which is? 19.5. So, the sum of 19.5 added to 19.5 is?
39 square feet.
39 square feet is right. Awesome. That's it, folks.